Hi, it's Ed Doherty again, part 2 of the Da Vinci Techno CNC CO2 Dragster project. I actually wanted to show you some other things. We were actually working on a project to use this in our house. This was a fixture that we made to run our house CNC, use our 4th axis. Only they don't do the shell cars anymore. We used to pre-machine the wheel wells and then put them on here and then screw them down with wood screws. And this would be our X0, Y0 coordinate, and we set Z0 to be this surface. We would rotate to one side, rotate to the other. But now we can't hold from the flat bottom anymore because everybody's machining in this area, so we can only hold from the ends. We're experimenting with an idea where we're going to use a larger piece of balsa and machine and use a tailstock on that end on our CNC machine. So that'll be in the next couple of months. We'll experiment with that. Okay. All right. We also we made a support to use that fixture with our tailstock. We did find that that fixture is not as accurate as a CNC machine needs, so it didn't rotate as well as we thought. Okay, so this is some other experimental stuff we've been playing with. We bought a couple of car kits. This is all new to us. This is the original shell car we had done on this fixture here. We'd made that. We would screw this onto here with wood screws, and we'd machine both sides. We'd rotate and rotate. So that worked pretty good, and it's unfortunate we're not doing that design anymore. Okay, here we are. We got our cars here, and when you spit it out in Mastercam, you can't spit out the whole program. It'll try to do everything. We're only doing left side right now. We got left and right. We've also dimpled the holes. We're not set up to do a drill, so we're going to dimple the holes, and they'll hand drill the holes in the dimpled positions. Okay, we're going to exit jog. I'm going to translate and execute, which means I prefer to take in all the files and put them in the computer. So I'm going to put them in my download file and Da Vinci file. I think that's the file I was using. I guess we'll have to go with that. Okay, paste. Okay, bring those in. Okay, this is Isabella left side, so I'm going to open that. Created using new default setting. Be sure to check setup before running file. Yes, do that. Okay, check your setup. Make sure these numbers match your numbers. 24.23, 103, and 12.45. Okay, save changes. Let's do a preview. Okay, can't see much there. Let's zoom fit. This is the file. This is similar to what we saw in Mastercam. You know, isometric. We got top view, front, isometric. So that's pretty much similar. You also notice that the white lines are rapid lines or retract lines, and we went with only 2 millimeters above our 34 millimeter setting, so we should have plenty of room. We decided to use full retract because we did not want to have any issues at all. Alright, and when we're running our CNC machines over there, we have the same graphics over there. We'll actually run it in the air. We don't have enough room to do that, but that would give you an idea of where everything's going to go. But we're going to have to, you know, if we had an extra, let's say 34 millimeters, we could move the offset up in the air, our tool length setting, move it up, and then run it in the air and see where it's going to go. Well, we have a couple extra cars, so I don't fear there's ain't going to be anything wrong here. So shut the doors. Vacuum cleaner works. We'll check our settings, preview, check our setup. Setup looks good, save changes, and you get your E-stop. So the only control you're going to have is this E-stop or the one inside. You can stop it. I'm actually going to do a jog here to show you how it homes before it moves. Okay, exit jog, and I'm going to do start. So you want to have control over what's going on. Alright, notice it goes home first. We're pretty close to the door, but we got plenty of room. Right now we have our cut speed at 458 and our plunge at 50. So we're going to just slow this down a bit. It actually takes a little while for it to catch up. I'm going to go down to 300 and 200. Put the vacuum on for a minute. You really want to review your tool path. There's been some issues in which the tool would try to go around the whole model. Like your CAD/CAM systems are going to try to machine every part of the model that it can get to from this orientation. So you have to set some containment barriers. Like we have to set some for the front, because if you cut the front off, it's unsupported. In the back, we've had issues with some other tools that literally cut through the shaft that holds goes through the hole. So you need to review your tool path visually in Mastercam and then on the Techno preview, so you can see that it's not going to go any place you don't want it to go. That's where if you dry ran this in the air, or literally you can dry run it without the part, that would probably not be a bad idea for your first timer, to have nothing in there at all. Have all your coordinates set and watch where it goes. Because now you can actually see and imagine what's going to happen. And as you gain more confidence, you'll be able to just keep on going along and machining more. You know, when we're in the metalworking industry, we wouldn't be doing cuts like that. We do rough cuts. You know, we'd have to rough it down. We wouldn't plunge headlong in the wood like that. We'd rough it down and bring it down close to the shape, and we'd let this tool do the fine cutting, and we'd also compress the tool path and into finer increments so that we have much smoother surface. We want to do as little work as possible at the end. We really don't want to do any handwork. We want the machine to do all the work. We're doing pretty good here, so we're just going around taking a look here. So we're looking at how much space we have underneath, you know, how it's held in there pretty well. It seems to be cutting on all sides. When you're designing this, you got to make sure you're not really designing to be near the boundaries of your material, because it may, if you don't get that material in there dead center, you may have one side machine, one side not machine. So that's really on the designer to don't be so close to the material boundary. Please be inside a little bit so you ensure you get the shape you want. You may be trying to gain weight or something like that, but you can't really, you're really stuck with the size of that blank and how accurate you can place that in here. Everything looks real good here. So so while this is running, you know, we got code here, all XYZ codes. These are what we call G01 moves in the G code world, and it means linear interpolation. So it's going from point to point. So to make a curve in 3D world, you have to have many points that are compressed together. And the finer that you can get them compressed together, the finer your finish will be. Of course, you've got to be able to have a machine that can interpolate all those numbers quickly, computer and machine. So it's very important that you can read that code that fast. Surprisingly, a CNC machine like these really can't hold that much code, but it only holds text. It doesn't hold the size of files that created the solid model. Those are very, very large files. So they're pretty much just text processing machines, or just just manipulating these numbers. But you get a very large 3D profile. One of my first jobs many years ago was working in a 5-axis prototype machine shop, and we had some programs that would run about 30 hours straight, like a prototype torpedo propeller or anything that had very elaborate shapes. Twisted blades were very, like a turbocharged impeller, very, very intensive programming. All right, everything's looking pretty good here. Put the vacuum on a little bit. Take a look around the shop while we're here. I feel pretty good about walking away from this because I've been running this for a while. Preview the code. Okay, so here we are in our CNC department. This is our 4th axis over here. I'm going to power this up right now. Okay, today we've been working on cutting steels. For instance, we were cutting some steel here and we had an issue with our tool, and it turned out it was running too fast, too much RPM. We were doing something called ramp milling, and we were trying to machine into this pocket. We wanted to clear this material out, so we're starting with solid. This is cold rolled steel, which isn't very, very, very tough steel, but it's much tougher than aluminum. So we have to get our feeds and speeds correct. A lot of material like wood, aluminum is very easy to cut. When you get into your exotic metals, here we have one we engraved the state of Florida logo on it, but we're going to make some of these out of stainless steel, which would be even more intensive programming. Okay, low air pressure. Turn our valve on in the back. Here, right here, is a chart here from the Iskar Carbide Tool Company on rates for different materials, and we calculate everything by surface feet per minute because tool sizes vary. For instance, if you're cutting titanium versus aluminum, there's a big difference in speed. So this is 50 to 150 surface feet per minute, with aluminum is almost 10 times that. So you have to cut titanium 10 times slower. Stainless steels, different stainless steels. We were cutting low carbon steel over here. Here's aluminum. Here's the low carbon steel. Okay. Gonna reset this. Turn the light on. This machine doesn't know where it is. It needs to be home, just like that machine needs to be home. So I'm going to do a power up restart, which brings the Z axis up. And it's going to bring the X and Y axis over, and that is a 4th axis, and that also has a home position, so that rotates 360 degrees. The same axis we used to make the Shell rotary car about 4 years ago. When we did that, we removed these vices and ran that fixture with a support plate on this side. Our tools we can set off of this probe right here. So for presetting tools, or let's say we're going to set a coordinate like where this is, we can do it much more high-tech over here. And we have a lot of room to work with. So if we're deciding we want it to be right there, we're going to call up our probe, which is tool 20. And there's our probe, the Renishaw wireless probe. Right here, this little probe talks to that wireless sensor. Now right now we are at machine home. This is set at the factory, but we need to know how to get there. So we're going to go into our probing system. EQC system. We're going to load the wireless template right here. We're going to use the simple probe 1 through 9. So we need to get the X coordinate, that'd be that direction, the Y coordinate from this direction, and the Z. So we're going to use this one first. We're going to use offset, we call it 54, G54 in the code. Is offset number 1, and there's a little picture here of where they want you to put the probe. I'm going to put that there. We're going to write a little macro program here, and I'm going to take my hand wheel and move that to that position. I'm going to move my hand wheel. I have different increments, so if I want to move it, this is actually moving right now in very, very small numbers, 0.0001. Now we're going to go over here. Over here, bring it down now, bring it down, and that's similar to the position. So that red ball is the point of contact, not this shaft. And this unit costs about $3,000, so you do not want to crash that. Okay, that's about where we want it, right there. I'm going to activate the MDI, which is a little program. We're going to run cycle start. Going to talk to each other here. Going to move, hit, coordinates. So right now we set these are all the coordinates. We have many, actually with that machine only has one, we have about 100 coordinates we can set. Okay. Alright, so now we're going to set the Y coordinate. We'll go back in here, grab a program. I'm going to do Y from the rear, the same coordinate, 54. We're going to write that macro to here, and we're going to move it around to the back. I'm going to move in this direction, and move in this direction, and we're clear. We don't want to be touching. We're clear. I'm going to activate this page and run that program. Now set that coordinate from home, and now we're going to write the last one. We only need 3, and we need to set the